As we have to cover a lot of topics, let's quickly start over with the new features inside our preprocessor ANSA. At the beginning, we have in the field of human body model, new human body model supported in the field of pedestrian, which is the GHBMC M50, the GHBMC M50 also in the field of occupant, as well as in the same field we are supporting the F05, the Thums AM50, as well as some Safer AM50, and Piper for the occupant 5 years old. Regarding the human body model tool, we will go through the human body model tool and we will articulate our human body model inside our preprocessor ANSA. Apart from these, we have new protocols supported in the pedestrian tool, which is the new one, the Euro NCAP version 9, which creates the windscreen rear reference line on the top edge of our screen, of our windscreen. Apart from these, the new tool creates also the wraparound distance 2500, as well as it creates target points for the bicyclists. Apart from the Euro NCAP in the pedestrian tool, we are supporting also the Korean NCAP 2022 proposal. Regarding our next tool, which is the brand new 3D slip ring, we are supporting in the seatbelt tool from the version 22.1.0, the effortless pass-through of a seatbelt through components such as the buckle and the D-ring, as you can see in this demonstration, and we will do this also in the live demonstration later on. Regarding the low-speed impactor tool, we have supported now a new protocol, which is the US Part 581 for marking and positioning from the front and the rear crash. In the next tool, we are supporting also new protocols, which are the seat positioning tool, which are for the front impact, the Asian NCAP, the Japan NCAP, the Korean NCAP full, as well as the Korean NCAP offset. Apart from the front impact, we are supporting also for the side impact new protocols such as the Asian NCAP, the Japan NCAP, as well as the Korean NCAP. Regarding the next tool, we have in the IP impact tool from the version 22.1.0 a new button for the positioning with different methods, as you can see them on your screen. Apart from these, we have supported also the scripting interface inside our IP impact tool with a base.ip impact scripting function. Talking about scriptings, we have the option from the version 22.1.0 to pop up GUI tools throughout the scripting for the seat positioning, the dummy articulation, the dummy marionette, as well as for the seat bot. Some small examples has been created from our side in order to run these and pop up the GUIs through the scripting. Last in the question safety discipline regarding on preprocessor ANSA, the new morphing through orthobox, which affects only the control points of our IGA in order to create smooth morphed shape. In the IGA field, we have supported also the automatic creation of an assembly point and a load case point on IGA holds, which creates also the constrained nodal rigid body automatically in a fast and easy way. And apart from these, we have also in this field supported the IGA include Bezier, which is a novel workflow with support of smooth splines by using the so-called Bezier extraction. Last but not least, in the field of IGA, we have supported new checks in that field, model data checks, as well as IGA entity checks. Let's move on now and start the live demonstration inside our preprocessor ANSA. As you might can see, I have opened the ANSA version 22.1.0. We will start off with the first model for our human body model. And you might be already familiar with the newest version of our tools and the preprocessor. We have switched the crash and safety buttons. They are lying now on the top main toolbar under the analysis tools. We have all the crash and safety tools here inside, and on the top we can see the human body model articulation window. Once the user opens the articulation window for the human body model, he will notice that this tool has three main tabs: the biofidelic move tabs, the rotate tab, and the translate tab. We will go through all these options by starting from the biofidelic move. Biofidelic moves are complex movements, are a combination of movements where more joints are taking part at the same time in order to perform these complex movements. The tool performs these movements by using a combination of both our multi-body dynamic solver as well as the morphing directly within ANSA. I need to mention at that point that we are the first preprocessor who has implemented this inside our tools or inside our software without the need to go to an external solver in order to articulate the human body models. Regarding the first step, the biofidelic move, it has on the top the metadata group, then we have the visibility group, the main window, and on the bottom of this group and this tab, we have the step total angle, as well as some options, which we will see in a couple of minutes. Regarding the metadata group, we have two options, from file and from model. From model means that the user is able to couple his own kinetics with the model. We will use the option from file, and once the option from file is selected, the user needs to upload a metadata file. The metadata file contains all the information. It is a so-called container with IDs of sets and kinetics of our model. Let's open up this metadata file for our human body model. All the necessary information in order to perform these complex biofidelic movements are stored in this metadata file. Once the tool opens up the window again, you will notice that in the middle, we will have these complex movements. And now we have the window being opened. We have all the complex movements in the main window of our biofidelic moves tab. As you might can see, if I expand one of these complex movements, we have more joints taking part in order to do this complex movement or perform this complex movement. Before proceeding, I need to mention that this metadata file can be used for a human body model of a same version in different solver, either with no modifications at all or with small modifications. The reason for this is that the kinetics which are inside these metadata file are deck independent, and the only thing which is deck dependent are the sets. That's why I mentioned previously that we might need to do small modifications. The next thing about the metadata file is that these files are created by us, the Beta CAE systems, and if someone wants to have them, he needs to contact us. So before proceeding, in order to articulate some of these complex movements, we will go through also the visibility option group. In the visibility option group, as you can see, we have 6 checkboxes. You can show or hide, for example, the skin of our human body model, the flash, which means these are deformable parts, all the deformable parts plus the internal organs. The skeleton of our human body model can be shown or hide inside the model window. And apart from these, we have also the option to deactivate the muscles or hide the muscles and tendons of our human body model. Apart from these, I will activate all of them again. We have 2 other options or checkboxes, the transparency and the angle. Regarding the transparency, once the user selects one of these complex movements, let's say that we will select the knee extension, and the checkbox transparency is still activated, the tool does the following. It highlights only the knee, and it sets the other parts of our human body model in a transparent mode. Apart from these, we will notice in a couple of minutes, once we have selected the angles, then the movement and the rotation of the parts will be highlighted inside the model window. Let's proceed to the articulation, but before proceeding, you might wonder why we have extension and flexion for these complex movements. This is a simple one. There are different morph constraints for the extension and for the flexion. That's why we have separated these 2 categories. We will start off with the knee extension, and I will deactivate for this one the skin and the flash. We will go on the bottom of our biofidelic move tabs in the human body articulation window, where we have the options step, which is set to 5, and the total angle. Let's type 30 at that point. 30 divided by 5 means that the tool will do 5 morphing steps in between. As we mentioned at the beginning, that we have a combination of our multi-body dynamic solver and morphing in order to perform these movements. Apart from these, I need to mention also that there is a guideline from our side. You need to use a step between 5 and 10. Try to avoid incremental steps. This could lead to mesh distortion. Once the user has defined the total angle on the bottom of our human body articulation window, he needs simply to click the green check mark if he wants to perform these 30-degree movement, or he can move the human body by the plus-minus button according to the step which has been defined. Let's perform this movement by simply clicking the green check mark, and as you will see, we will have 6 steps being performed from our human body model tool. There is also the illustration for the movement inside the model window. As you can see, if I deactivate the angles, then these movement will disappear from the model window. I will activate the flash in order to inspect the morphing which has been done. As you might can see, we have a perfect model and a perfect result at the end. And I will show also the skin of our human body model in order to show you that the morphing has done a very good job. Apart from these, let's perform this movement again by having only the skeleton activated. In order to move to the initial position of our human body model, there is a button on the bottom of this biofidelic move tabs and this human body articulation window, the initial. Initial means that this is the initial position where we have loaded our human body model inside our preprocessor ANSA. Once you click the initial button, the human body model moves at its initial position. We will deactivate the skin, the flash, and the muscles, and we have the bones, as well as you might can see, we have the patella. The reason why I am performing this movement again, I would love to show you that there is not a simple rotation. We have a rotation of the patella on the bone, and at the same time, we have a gliding. Apart from these, the tool takes into account the contact thicknesses, and at the end, we will get a penetration-free model. Let's click again the green check mark, and as you might can see, we have a rotation and a gliding at the same time. If we zoom in, then you will notice that the result is very good, and we do not have penetration. If we activate also the hidden parts of our human body model, such as the muscles, we will see that the result is very good, and we still have no penetration after the morphing and the multi-body dynamic solver takes or does his actions. Apart from the knee extension, let's move on and perform some other complex movement. Let's say that we will do this for the shoulder extension. In order to perform this movement, I will deactivate again the skin and the flash, as well as I'm deactivating the checkbox transparency. The reason why I'm doing this is there is, according to the literature, a body anatomy rule for the shoulder, which says that once we raise the shoulder up, we rotate the shoulder 30 degrees, the shoulder bone, which I'm highlighting now with the mouse cursor, is taking also part in this movement with 15 degrees rotation. And exactly this is the case also in our human body model tool. Let's type in the total angle field 30 again and click the green check mark. Just simply look on the right-hand side of our human body model. And once we perform this movement, the shoulder bone is taking also part in this movement as it should be. Apart from these, we will move on and we will see some spine movements. Let's say that we will perform deflection. There is another point which I need to mention. The user needs to define positive value when he is extending a part of our human body model. And when he chooses deflection, he needs to type a negative value. We have modeled each vertebra of the spine with more than 2 degrees of freedoms in order to rotate and glide at the same time. Just simply look on the upper body of our human body model. Once I'm selecting the pelvic lumbar flexion, I'm typing a negative value, -20, let's say, and I'm clicking the green check mark again. You will notice that the upper body of our human body model moves. And as you can see, we have successfully performed also this movement. Let's inspect the result. It seems to be at the end very good. If we deactivate the skin, as well as if I'm deactivating the flash, you will notice that the tool does a really good job. Apart from the biofidelic move tabs, we have also two other tabs, which are the rotate tab and the translate tab. Regarding these two tabs, these are simple movements. We have still inside these tabs the availability option group. As you can see, this is a so-called dummy hierarchy when we are talking about the rotate tab. We have these joint tree. We will select, for example, let's say that we are selecting the right hip of our human body model. And in order to perform this simple movement, we need to select the rotation axis. As you might can see, inside the rotate tab of our human body model, articulation window, the R axis has been selected. It appears green inside the model window, which is the rotation axis. There are two ways how the user can perform these movements. Either he will define a total angle in the total angle field, let's say 20, and click the green check mark again, or he will perform this movement directly throughout the model window by simply clicking on the left mouse button and moving the hip to the position which we want to have, which is the desired position. Let's say that we will move these to -17. As you can see, the morphing takes part, and at the end, we have a perfect result. Apart from these, we have also the translate button where the user can translate the human body model into the space. He can move the human body model in the space. Just let's open up also a sheet in order to do this translation. We need to open up again the human body model articulation window. We will click on the translate tab and we will select one of the two options. The first one is the target point option. If the user selects a target point option, he needs to select the ending node, and this will do the following thing. It will match the hip point of our human body model with the node which has been selected. As you can see, a green arrow appears inside the model window, and once we are clicking the green check mark, the human body model moves to this position. So we have now a match of the hip point of our human body model and the seating reference point. Apart from these, we have also from this drop-down menu the option vector. Vector means that the user needs to select two nodes in order to define the vector. As you can see, the distance has been written also in the D field, and the user needs to click the plus or minus button in order to move the human body model to the positive direction or negative direction. Let's say that we will select the plus button twice, and we will select two different nodes in order to change the vector, the first one and the second one, and we will click again the plus button. Let's assume that this is the desired position of our human body model. The last thing about our human body articulation window are the four buttons which I have mentioned at the beginning on the bottom of this human body articulation window. There is the option output, and the option output does the following. It saves a star node keyword with all the nodes in the new coordinates. Let's save one. We'll use this NO key. We will override these, and we will just simply open this file. As you can see, it has a saved in star node with all the coordinates only, and with all the nodes with the new coordinates. As well as we have the options inside the human body articulation window, which says previous. We have seen already the option initial. There is a main difference between previous and initial. Initial means that the human body model moves to the initial position where we have loaded it inside our preprocessor ANSA. Previous means that is the previous position of our human body model when the human body model tool has been opened. Regarding the save button means that the tool saves a kinetic position which can be reached throughout the database. Let's perform this one. It opens up the kinetic position window. Let's type the name human body model and click the enter button. Once the kinetic position has been saved, you can inspect this position inside the database browser. In the group kinetics, there is a kin position. It opens up this window where we have successfully saved this kin position of our human body model. Let's perform this movement by simply clicking the initial button in order to move the human body model to its initial position. Let's do this again. And let's move that human body model to the saved kin position by simply selecting the human body model position, move to position. As you can see, the human body model has successfully moved to the position which we have saved previously. Apart from these, if the user wants to load the star node keyword file which has been saved, he can simply do this by file, input. The LSDyna is the selected deck, and he needs to load the new file with the new coordinates of all the nodes of our human body model. This is pretty much all about the human body model articulation window and such an easy way the user can perform this movement of the human body model and take the advantage also of our biofidelic moves. Let's proceed on with the next tool inside our preprocessor, which is the pedestrian tool. For this reason, I will open up the next model, which is the Rogue V1. You will notice once the model is opened inside the model window, I have already created the target points. The reason is I have done this in order to save some time, but we will go through each point in order to create these points. Again, the tools for the crash and safety application lies now under the analysis tools. We have the pedestrian, and it opens up the pedestrian tool. The pedestrian tool has three tabs: the car marking tab, the target positioning tab, the target point tab, and the positioning tab. In the car marking tab, we have on the top the drop-down menu where all the protocols which are supported lies there inside. I have selected the Euro NCAP in order to create the target points, which you see now inside the model window. In order to proceed, the user needs to define also the empty fields for the external part, windscreen, bonnet, and A-pillars. Let's inspect these sets. We have the external parts, the windscreen, the bonnet, the A-pillar both, as well as the front bumper, in order to mark according to the new protocol, which is the Euro NCAP version 9. Once the user has defined all these sets, he needs to select the ground type, either flat or inclined. If you select the flat option, just simply click inside the P1 options, hit the F1 keyboard button. This allows you to select a node from the model window. I have selected these nodes. This node there has the same coordinate as the lowest node of the tires. The Z coordinate is the same as the lowest node of our tires. So once this has been done, the user needs to click the mark button, and after a couple of minutes, he will have all the target points being created. Once the tool creates all the target point, he stores these target points also inside the database, where you will find a safety group with all the target points. Let's start off with the new curves being created. Let's open up the curve window. The new one which has been created from the protocol, the Euro NCAP version 9, is a rear reference line for the windscreen, for the upper edge of the windscreen. Apart from these, the tool creates also the wraparound distance 2500. Keep in mind that for this protocol, points lying between the wraparound distance 2100 and 2500 are all points for the bicyclists. Apart from these, we have a squared box, a rectangular box in the middle of our windscreen, which is the green zone line for the windscreen. All the points lying inside that green zone are safe points and they appear marked in a green color. Apart from these, let's move inside the database, the safety group, and open up the target points. You might notice that there are different target points starting with a A, B, and C. The points for the bicyclists have inside the name the letter B. If the user types in this search function the letter B, he can see all the points related to the bicyclists. Once you select the point and we will inspect them, you will notice that points lying above the wraparound distance 2100 and below the wraparound distance 2500 are all points for the bicyclists. Apart from that, just simply look inside in this point. If I zoom in enough, these lies outside these two edges. That's why it doesn't belong to a target point for the bicyclists. Apart from these, if the user wants to delete all the points in order to select a different protocol, he can click the undo all button. The tool will delete all the target points. He can select the other new protocol, which has been also supported from the version 22.1.0, which is the Korean NCAP 2022. Fill all the necessary fields, define the ground type, and just simply click the mark button. And after a couple of minutes or seconds, the tool will create all the target points. We will not perform these target point creation as we have to cover a lot of other topics. The next tool which we will see is the seatbelt tool with a brand new 3D slip ring. For this one, I will open the next model. And as you might can see, we have a dummy which lies on the seat. In order to activate, it sits on the seat. In order to activate the seatbelt tool, we need to go again under the analysis tools, the seatbelt tool. And as you can see, I have already created a seatbelt. There are three different options how the user can create a seatbelt. Inside this entity list group, right-click New, either a default one, a 3.1, or the option from template. I have used the option from template and I have created previously a 3-point seatbelt. We will go through each of the points in order to successfully create a seatbelt. If the user clicks the 3-point seatbelt, he will have such a tree. The first thing which you need to do is you need to select the parts to wrap by simply click on the parts to wrap, right click, select parts. I have selected for this example, these parts to wrap. Apart from these, the next step which the user needs to do is he needs to define all the components. We have component 1, which has renamed from my side as a lab component, component 2, which is a shoulder component, and component 3, we have the Such Guide component. Let's start off with the lab component. We have the parameter group on the top, on the lower window of this seatbelt window, where the user needs to define the generic type 2D seatbelt in order to activate the new button, which is this button, the 3D slip ring area button. It's highlighted blue now, as you might can see this inside your graphical user interface. Apart from these, the user needs to move on and define the starting part for the first component. I have selected in our example the element type none and the Ensure entity fixed. If the user clicks on this Ensure entity, he will notice that in this drop-down menu, the option of 3D slip ring has been faded out. The tool is smart enough and it recognizes that for the starting part, it doesn't need to pass any seatbelt through a component. That's why for the starting part of the first component, the option is faded out. Moving on to the main part 2D, the user needs to select the element type. I have selected element 2D belt. He needs to define the number of shells and the width of our seat belt. And keep in mind that if you want to have the same PID for the whole seat belt, you are able to define a PID here, and the same PID needs to be defined for the lab and the Such Guide component. Once all the fields has been defined, the user needs to select or pick two nodes from the model window in order to define the entry vector at the beginning and the exit vector. Just simply click inside one of the fields of the entry vector, hit the F1 keyboard button. This allows you to select nodes from the model window. I have selected the first node and the second node in order to define the entry vector for our seatbelt. Regarding the exit vector, the same procedure, click the F1 keyboard button, and in our example, I have selected the first node here on the buckle and the second node in that. Keep in mind that the vector orientation for all the components of our seatbelt must be in the same direction in order to get the best result out of our seatbelt tool. Once we have defined the two vectors, the user needs to proceed to the ending part. In the ending part, I have selected the element belt 2D as well as the ensure entity now 3D slip ring. Once the 3D slip ring option is selected, the 3D slip ring PID field gets activated. The user needs to select at that point the PID of the part where the seatbelt of the component where the seatbelt will pass through. I'm clicking now the question mark. It opens up the property help window. The user is able to select a property from this window or directly from the model window. I have selected the buckle. The confirmation can be done with the middle mouse button, and we are able to proceed to the shoulder component. Keep in mind that ending part of one component are automatically the starting part for the other component, as well as the exit vector for the lab component will be automatically updated for the next component, which is in our case, the shoulder one. As you might can see, if I select the shoulder component and we are going on the top, we have the same parameters. We have the starting part being already defined. It's a 2D belt element with a 3D slip ring with the same property being selected, the property from the buckle. And we need to define now only the exit vector for the main part 2D. The exit vector for the shoulder component is where I have selected two nodes on the D-ring, the first one and the second one in the same direction. Moving on to the ending part, we have selected the element type 2D belt as well as the ensure entity. And at that point, for the shoulder component, the 3D slip ring PID on the bottom of our seatbelt tool has been selected. I'm clicking now the question mark. We have selected, in our example, the D-ring. I'm confirming with the middle mouse button, and we are able to proceed to the chassis guide component. Regarding the chassis guide component, the procedure is pretty much the same. The starting part has been automatically updated from the shoulder component. We need to define the exit vector for the main 2D part. Just simply click again inside that field, the F1 keyboard button, and select the two nodes in order to define the vector. I have selected two nodes in this same direction in order to get the best result out of our seatbelt. And we are proceeding to the ending part of the last component for our seatbelt, where we have defined the element type none and as an ensure entity, the option fixed. Once all the components has been completed, the next thing which a user needs to do, he needs to click on the top in the parameter group, the 3D slip ring area. Once the user clicks this button, the tool will highlight only inside the model window, as you might can see on the right-hand side of your screen, of the two PIDs which has been selected in the field 3D slip ring PID. As you can see, we have the buckle and the D-ring. Let's inspect the elements which has been selected from our side, where the seatbelt will pass through. We have the elements being selected from our side, where the seatbelt will pass through for the buckle, as well as for the D-ring, these elements has been selected. Keep in mind that if the user forgets to select these elements, the tool is smart enough and it will detect the elements by default and automatically. So you don't need to click this button if you forget these, the tool will select some elements, pretty much the same elements which I have selected in our example. The last thing which the user needs to do is he needs to select or pick some points where the seatbelt will pass through. This can be easily done by simply select the first component, right-click, pick points. You need to select 3 points for the first component, the second component, and in our case, we have selected 2 points for the third component. These points can be inspected if we expand this list. As you might can see, if I'm selecting all the nodes and I'm clicking the highlight button, we have selected the first node at the starting part of the lab component, the second node on the dummy, and the third node on the buckle. Keep in mind that you need to select a node on the elements which has been selected previously in the 3D slip ring area where the seatbelt will pass through. I will click again the 3D slip ring area button. As you can see, we have selected these elements. So you need to select the third node for the first component, or we have selected the first node for our lab component on the elements where the seatbelt will pass through. In a pretty much similar way, the user needs to select the other 3 nodes. The first node, as I have mentioned these previously, is automatically selected because the ending part of one component is automatically starting part for the other component. The second node has been selected on the chest of our dummy, and the third node has been selected on the elements of our D-ring, as you might can see. For the chassis guide, we have selected 2 nodes, the first one on the D-ring and the second one on the exit part or on the exit vector for our chassis guide component. Once these points has been selected, the last thing which a user needs to do is he needs to select the 3-point seatbelt entity, right-click, and create the seatbelt. Once these buttons have been selected, as you can see, the tool creates the first component. There are some blue dark dot points where the user is able to modify the position of the seatbelt. We will not perform a modification. We will simply confirm this one. The tool creates the second component, which is a shoulder component in our case. Again, the points, the dark blue points appears for the shoulder component. We can modify the position of these component. And once we confirm these shoulder component, you will notice that the seatbelt has been created. Let's inspect now the effortless pass-through with the option 3D slip ring. As you can see, if I'm zooming in on the D-ring, the seatbelt has been passed through the first component and the second component, which is the buckle. As you can see, we have a perfect result, a perfect pass-through in such an easy way throughout our tool from the version 22.1.0. The option 3D slip ring can be used in such an easy way. Let's move on and proceed to our next tool, which is the low speed tool. And we will clear the database and open up the next model. Again, we will open the Rogue V1 model. Once the user selects or he needs to use the low speed tool, he needs to keep in mind that he needs to include the impactor in a different include. This can be simply done by using the file input LS-DYNA option, select the impactor and use the checkbox input in a new include. The reason why we are doing this for this tool is simple. During the position, there is an option in order to select the impactor and it opens up the include help window. Let's see the tool. The tool lies again under the analysis tools. We have the low speed and it opens up the low speed impactor tool. There are 2 tabs, the target point and the positioning tab. The new regulation which has been supported is the US Part 581. We need to select the front bumper by simply clicking the question mark and select the front bumper, confirm with the middle mouse button, click inside the rear bumper field, hit the question mark from your keyboard and select the rear bumper. Once this has been done, the ground type needs to be selected, and once the user selects the option flat or inclined, then he needs to click on the calculate button. According to the protocol, the tool creates the target points for the front bumper and the rear bumper. Let's inspect these tools, or let's inspect these target points. They are lying inside the database under the safety group. According to the protocol, we have 10 points for the front bumper, as you can see, and 10 points for the rear bumper. In the middle of each bumper, we have 2 points, the 16-inch and the 20-inch according to the protocol, and for each side we have 4 and the other 4 points. Let's say that we will position the impactor on one of these created position according to the new protocol. The user needs to go to the positioning tab. He has the option to do a multi-position or a single point positioning. We will select the multi-point positioning. The reason why we have inputted the impactor in a new include is exactly this one. If I'm selecting the impactor field and I'm hitting the question mark, then the include help window pops up. We will select the include of the impactor, and we will confirm with the middle mouse button. Apart from these, the user needs to define also the bumper. Keep in mind, if you want to perform a multi-point positioning, both impactors needs to be in one set. We will do these only for the front bumper because the procedure is exactly the same. We will select the coordinate ID of our impactor, and we will proceed by selecting the target point. And let's say that we will select the target point exactly in the middle. We will hit the target point 9 for the 20-inch positioning according to this protocol. The last thing which the user needs to do before hitting the positioning button, he needs to define the ground type by simply selecting the question mark in order to be able to pick a point from the model window. We will select again the 3D point, which has the same Z coordinate as the lowest node of our tires, and we will hit the position button. Once the user hits the position button, as you can see, the impactor has been successfully positioned. In such an easy way, the user can create the target points according to the new protocol, which is the US Part 581, and position the impactor on the created target points. Let's move on and proceed to our next tool where we have supported new protocol, which is the seat positioning tool. For this one, I will open up the seat which has been seen previously in our human body model. Regarding the seat positioning tool, it lies again under the main toolbar analysis tool, seat positioning. Once this wizard opens the seat positioning window, you will notice that we have on top either the front impact options or the side impact options. Apart from these ones, or the protocols which are supported for the front and side impact, we have also the bottom custom one. As you might notice the difference, once we are changing the protocol, let's say from the Asian NCAP to the Japan NCAP, the illustration below these two buttons changes. The very interesting about this tool is that the user doesn't need to know anymore the regulation. All the know-how is stored inside that tool. The procedure is pretty much the same. So we will do a seat positioning for one of these protocols. Let's say that we will select the Japan NCAP, and we will proceed with the next button. Once the user clicks the next button, the fields tab where we need to define the field PID on the top is activated. So we will select the field PID by the button which allows us to select a PID from the property help window or from the model window. I'm selecting the seat field from the model window, and I'm confirming with the middle mouse button. Once the confirmation has been done, the points which can be seen in the illustration and all the coordinates for this point has been automatically updated. The user is able to clear these coordinates by the button on the right-hand side in the seat positioning tool. Last in the fields tab is the seating reference point body ID. In order to activate the next button, the user needs to select the seating reference point. We will click on that button and we will select the seating reference point from our model window, confirming with the middle mouse button, and the tool allows us to proceed. There is something very, very interesting and smart about this tool. I will open up the kinetic configuration, the kin configuration, which has been created for our example. As you might can see, we have created a backrest configuration, a slider configuration, as well as a height configuration for this example. Just notice that the tool has automatically selected the configuration ID. The tool recognizes names such as slider, backrest, and height. And once he is on the step regarding the slider, he will automatically select the configuration ID as it has been done for this slider configuration. In the seat for aft, once the tool recognizes the configuration for the slider, it updates automatically the configuration actuator joint information, as well as on the bottom we have the adjustment characteristics according to the Japan NCAP protocol which we have selected. The user is able to modify these adjustment characteristics by simply selecting the adjust articulation by the actuator joint and type a value. We will not do this for this step, and we will proceed with the next button. Before proceeding with the next button, let me move the seat positioning tool inside the database. Just simply look on the right-hand side of your screen. There are options on the bottom of our seat positioning tool, the animation speed bar, the preview button, the undo button, as well as the skip current adjustment button. Once I will click the preview button, the preview of this movement will be seen inside the model window. Just look on the right-hand side, I'm clicking the preview button, and the seat moves according to the slider configuration. If you perform this movement, you need to click undo before proceeding. Let's proceed with the next button to the seat height step. The tool recognizes again a configuration called height. It updates automatically all the configuration actuator joint information, as well as the adjustment characteristics for the Japan NCAP protocol. Let's say that we will modify the ones. We will select articulate by the actuator joint, and we will type 20 degree for the height configuration. There is still the option on the bottom, the animation speed bar, the preview, and the undo button. The preview button now has a drop-down menu where the user is able either to preview the current movement or all the movements. Let's say that we will preview all. Look on the right-hand side of your screen. Once we click the all button, the seat moves according to the slider configuration and the height configuration. Click the undo button and proceed with the next button to the seat back angle configuration. In the seat back angle step, the procedure is pretty much the same. The backrest configuration has been automatically recognized. If this is not the case in your model, just simply click inside the configuration ID field, hit the question mark. It opens up the kin configuration help window where you will be able to select one of the configurations for your seat. All the necessary information is stored in the configuration actuator joint. And let's say that we will modify again the adjustment characteristics by selecting the articulate by the actuator joint and defined for the backrest configuration a rotation of 20. We will not preview this movement and we will proceed with the next button. There are 3 other steps where we do not have create a configuration. That's why there is an option skip current adjustment on the bottom of this seat positioning tool. Once the user clicks on this button, the next button gets activated in order to proceed. We will proceed in the same way for the head restraint for aft step. We will click the skip current adjustment, as well as we will do the same thing for the base tilt, because in this example, we do not have a configuration for the base tilt. So I'm clicking the skip current adjustment and I'm proceeding with the next button. Once the summary step has been reached, on the top, the protocol which has been selected appears. Protocol is the Japan NCAP. Then the 6 steps of these protocols appears the one where we have selected something and the ones which we have skipped. The position name is the Japan NCAP underscore frontal. The reason why the underscore frontal appears is that we have a Japan NCAP positioning protocol supported also for the side impact. Below this positioning name, we have the preview of the script, and there is a button Save Script where the user is able to save also the script. Apart from these, we have also still the animation speed bar, the preview button, and the undo button. Let's preview all the movements by simply clicking the preview button. Just look on the right-hand side of your screen. The three movements where we have selected something, or the three configurations which has been created from our side, are moving the seat to the desired position according to the protocol. We will click the undo button and we will hit the finish button. Once the user clicks the finish button, the information that the Japan NCAP frontal position has been successfully created appears. If the user clicks the close button, the seat positioning tool closes. The position which has been stored can be inspected inside the database under the group kinetics, kin position, and the Japan NCAP frontal position appears. As you can see, an illustration of these positioning, or the positioning once we select the position, the kin position which have been saved, and we activate the highlight button, and the pick button appears highlighted in a red color inside our model window. If the user wants to move the seat to this position, he needs to simply select the Japan NCAP frontal position which we have saved, right-click, move to position, and the position has been successfully moved to the stored kin position. In such an easy way, the user doesn't need to know anymore all the protocols. He needs to go through all the steps of our seat positioning tool in order to create and save the position according to the protocol. Let's move on and proceed to our next tool. We will open up, for this reason, the IP impact tool. You will notice that once the model opens, I have already created the target points. The reason again for this is in order to save some time, but we will go through all the points in order to create the target points and position them according to the new option or the new feature, which is the positioning feature with methods. Regarding the IP impact tool, the tool lies again under the analysis tools. Inside the interior, there is the IP impact. Once the user selects the IP impact tool, the instrument panel impact window opens. There are two tabs, the marking tab and the positioning tab. For these target points created from our side, we have selected the FMVSS 201. We have defined the sets such as the IP, the steering wheel, as well as the windscreen. We have selected the H point offset according to the seat XZ offset, and we have defined the left-hand side seating reference point by simply clicking the F1 keyboard button and select the left-hand side seating reference point, as well as we have defined the right-hand side seating reference point in a similar way by hitting the F1 keyboard button and selecting the right-hand side seating reference point. In the target point drop-down menu, we have selected on specific distance, and we have clicked the button marked in order to create these target points. Apart from these, there is also the advanced button. In the advanced button, we have all the default marking parameters as well as options for the H point offset. If the user is able to modify these marking parameters and H point offset, and he's able also by the button Restore Defaults to restore the defaults. Apart from these and the new method which has been supported from the version 22.1.0, we have the positioning tab. In the positioning tab, as you have seen this already in the presentation, we have the methods where we have supported different positioning methods from our version 22.1.0. The user is also able to do a single point positioning or a multi-point positioning. We will move on with a single point positioning, and we need to define all the necessary information, such as the head form, by simply selecting the head form from the model window, the coordinate ID of the head form, which is this one. Then we need to select the IP as well as the pivot node. We will select, in our case, the right-hand side seating reference point as a pivot node, as well as we need to select also the target point by simply clicking the question mark. It opens up the target point help window. Let's say that we will select the target point from the front row, this one here, and confirm with the middle mouse button. Now, in order to position according to the methods, the user needs to select one of these methods. We will do these for, not for all of them, for one of them. Let's say that we will position according to the 90 degree, and 90 degree means that it positions the head form by applying a 90-degree angle between the head form and the target point. And the only thing which the user needs to do is simply click on the position button. Once he does this, the head form has been successfully positioned. Let's inspect if the 90-degree positioning has been done correctly from our tool. In order to do this, I will hit the F11 keyboard button. We will go to the presentation parameter. On the bottom of this window, we have the draw size of the coordinate system. Let's type 100, click the apply and the OK. This will expand the coordinate ID of our head form. If the user clicks the Control and Shift button, you will notice, or he will notice, that the target point or the head form hits the target point exactly 90 degrees with the method 90 degrees, as it should be. In such a simple way, the user can mark and position according to the methods with the help or with our IP impact tool inside our preprocessor. Let's change the drawing size again back and proceed. Moving on, in these two, we have supported also the scripting interface, which the user can find under the tools toolbar, script editor. If he goes on the right hand side in this function list and he types IP impact, then he will notice that the IP impact appears. The base.ip impact appears, scripting function, which has been supported from the version 22.1.0. Talking about scriptings, we have supported also the pop-up GUI through the scripting functions for the seat positioning, the dummy articulation, the dummy marionette, as well as the seatbelt tool. For this reason, we have created some examples for the dummy articulation window. The function is called base.dummy articulation window. And once the user clicks on the run button, you will notice that the dummy articulation window will pop up. As you can see, the dummy articulation window pops up inside our graphical user interface. In a pretty much similar way, if we open up the next example, which is the seat positioning wizard, once we click again the run button, the seat positioning tool pops up. Apart from these, the user can also type inside the function list the scripting for the dummy marionette and the seatbelt by simply typing marionette. Show window is the function for in order to pop up this GUI, and for the seatbelt, the A seatbelt that show appears on the bottom of this function list in order to pop up GUI tools such as the seatbelt. Last in the discipline of our preprocessor ANSA, we have some new developments or new functions supported in the field of IGA. For this reason, I will clear the database. We will open up the next model, which is the IGA morph. As you can see, the first new option or new function which has been supported is the morphing throughout the orthobox for the so-called, from my side, IGA shell. In order to inspect the IGA mesh, and I'm calling these the IGA mesh, we need to open up the module buttons, need to go on the topo, and inside the auxiliaries, we have the IGA modify. If the user clicks on the B pillar, then he will notice that the so-called from my side IGA mesh appears. Let's now move on and see the new feature inside the version from the version 22.1.0, which is the morphing throughout the ortho box. The only box which works for the moment for the IGA is the option ortho. We have created for this example 2 parameters. We are modifying the width of this B pillar as well as the height of that B pillar. Once the user has created the parameters, the only thing which he needs to do is he needs to select the parameters, right-click, morph. Once he clicks the morph button, then he will notice that the parametric movement window opens up. He needs to type a value. Let's say that I will type 5. Just simply look inside the model window. Once I'm typing 5, we have successfully morphed the width of our IGA, confirming with the middle mouse button and clicking OK, and the morphing has been stored. And we will select also the height transformation parameter which has been created in order to modify or to morph the height of our B pillar by simply selecting the height transformation, right-click, morph. Once the user types a value, let's say 10, he has successfully morphed also, in our example, the height of our IGA. And once he confirms with the middle mouse button and he clicks OK, then the width and the height has been successfully morphed for our IGA. Apart from these, in the field of IGA, we have supported or we are able to create assembly points and load case points. For this one, I will open up the next model. As you might can see, this model has 2 holds. For the IGA holds, we have supported these in order to create the assembly point. The user needs to go on the top toolbar, the assembly toolbar, select the subsystem assembly points. It opens up the A point window, right-click inside that window, new, on holds. It opens up that window. We have selected the option, work on visible, preview, the diameter from 0 until 15, where the tool will search for holds, and we have the interface type RBE2. Keep in mind from this drop-down menu, we are supporting now the A point creation and the LC point creation for the load case only for RBE2 and RBE3, not for rigid patches. We will select the RBE2 and we will click OK. Once we are clicking OK, the tool recognizes both holds. We will deselect by the right mouse button the first one, and we will confirm with the middle mouse button. Let's close these. And as you can see, if I click the refresh button, the assembly point has been successfully created, as well as the constrained nodal rigid body for the assembly point. The created assembly point can be inspected inside the database. Under the group interface point, there is the A point. Apart from the A point, the user is able also to create load case points. In order to do this, he needs to activate again the model button, because I use the X button in order to hide them. He needs to go under the deck LS-DYNA. Keep in mind, IGA works only for the LS-DYNA deck. He needs to go on the auxiliaries, and there is the option LC point. Once he clicks on the LC point, the LC point window pops up. Again, right-click inside, new, on holds auto. The options are the same, work on visible, preview, 0, 15 diameter search, and the interface type RBE2. Once we are clicking OK, the tool recognizes again both of these holds. The very interesting and nice about this tool is that once we select the A point, the tool is smart enough and it shows us that this is already an assembly point created. So we will deselect this again by the right mouse button, confirm with the middle mouse button in order to create the LC point. If we refresh also the LC point window, you will notice that the status appear OK. The tool creates also in such an easy way the LC point as well as the constrained nodal rigid body for our load case point. Apart from these, we have supported also from the version 22.1.0 For the IGA, the smooth splines using the Bezier extraction, the user can use the search function on the top right corner. If he types the word Bezier, then the option star include Bezier appears, as well as we have also the option there a list. Last but not least, in the field of IGA, we have the ones which we have seen previously, the model data check, as well as the IGA entity checks. I will open up the last model in our preprocessor. We have some IGA shells, and in order to perform the check, the user needs to go on the top toolbar, Tools toolbar, Checks. We have modified a little bit these drop-down menu. The IGA checks appears under More IGA entities. Once the check manager opens, in order to identify penetrations, the user needs to activate the option Check Penetration Intersections by these checkbox there, and he needs to click the Execute button. Once he clicks the Execute button, as you can see, the tool has recognized one warning and two error message. The warning says that the IGA shell has property of type star section shell instead of star section IGA shell, and the error messages are saying that we are using in this model a mix of an old type and a new type, as well as the intersection between the PID3 and the PID4 gets recognized through the IGA checks entity. This was pretty much all the new features which we have from the version 22.1.0 in our preprocessor. Let's keep it fast. We will proceed in a pretty much similar way. We will fly over the presentation of the newest tools of our post-processor Meta, as well as some new features which we have, and then we will do the live demonstration inside Meta. Let's open up for this reason the presentation for Meta. For those of you who have not seen the Meta presentation with the latest developments in the crash and safety field, there is a new tool from the version 22.1.0, which is called the deployable bonnet system assessment, which evaluates the timing of the system deployment. It creates the head impact time and the wraparound, or it calculates the head impact time and the wraparound distance. Apart from these, it creates a combination of a plot for all the pedestrian stages between the wraparound distance and the head impact time, and it assesses the bonnet deflection due to body loading. Apart from these, we have also a new tool supported from the version 22.1.0, which is the FMVSS 226 for the evaluation and reporting of the ejection mitigation results. This tool can be used for one glazing, for one side airbag, for one side window, and up to 5 airbags at the same time. And now we are supporting the DEX for LS-DYNA, PEMCRASH, and Radius for these two. Apart from the new tools, we have also in our massive tool, the Occupant Injury Criteria tool, some new features where the user is able to select and swap the position of some plots by simply clicking the Swap Plot button, as well as we have supported the new protocol for the Side Impact IIHS version 2 2022 from version 22.1.0. Apart from these, some injury risk probabilities of Thor 15 for the US NCAP has been supported. The GHB M95 as well as simplified models has been supported. The H350 and 05 for ATD, as well as more results for Thor 50, H305, H3 3 years old and 6 years old has been also supported in the Occupant Injury Criteria tool. In our next tool, we have also supported a protocol, which is the Side Impact IIHS version 2 2021. The IIHS structural rating has also supported the user-defined limits for the side impact from the version 22.1.0. Last but not least, in our post-processor Meta, we have supported in the pedestrian field the new protocol for the Euro NCAP, the version 9 2023. Let's keep it going and move on with a live demonstration inside our post-processor Meta. You might be familiar already with Meta. All the toolbars for the disciplines, they are lying under the main toolbar, user toolbar, crash and safety application, and we have all the tools here. On the bottom of this drop-down menu, we have the FMVSS 226, which is the first tool which we will see inside in this live demonstration. Once the tool opens, on the top, we have the read configuration file. The user can set all the necessary fields once, write a configuration file, and use these in order to make his job easier and faster. The tool consists of 3 tabs. We have the Process Target Point tab, the Result Overview tab, where the user is able to map the annotations and values on his model, as well as the Settings tab. Regarding the Settings tab, we have on the top the Process Target Point Settings group, as well as on the bottom, we have the Result Overview Settings group with 2 columns, the Max Displacement and the Excursion. We will see these values and these colors later on in the report, which will be generated automatically from the eFMVSS 226 tool. Let's proceed on with all the necessary fields from the process target point. As you might can see, on the top, we have the result type, either airbag and glazing, only glazing, and or only airbag. Once the user selects, for example, only the glazing, below 1 tab glazing appears. If the user selects the airbag and glazing, a tab glazing as well as a tab airbags appear. We mentioned the point previously that the tool can operate at the same time for 1 glazing and up to 5 airbags. And in order to select more airbags, we need to click the airbag version drop-down menu or button and select the option 5. Once the option 5 has been selected, 5 tabs for all the 5 airbags appears. We will proceed on with 1. We will keep this simple in order to get fast results and a fast report. Apart from these, we have also in the format group the orientation X of the car, either negative or positive, the impact side left or right, the file formats being supported, either PEMCrash, Radius, or LSDyna. And apart from these, the user needs to select the units which he has also used for the simulation. Then we have the result type directory where the user needs to select the folder where all the simulation lies inside. The target point file is a file which can be extracted from ANSA, and I will open up for this one a target point file in order to show you how this target point file looks. It is a file with 2 of the 4 points of this protocol with the coordinates and some values inside. We have saved a configuration for these 2. I will open up this configuration. And once all the necessary fields have been filled, the user needs to click the process result button. Once he clicks the process result button, the first window which appears because we have selected the option through GUI on the process target point step or group is for the glazing. We have 2 simulations for the glazing. I need to mention at that point that the protocol or this protocol operates in 2 different steps. The first step is that the head form hits the glazing without an airbag, and the second step is that the head form hits the airbag, the open airbag, without the glazing, without the side window. So the first window which opens up is for the simulation regarding the glazing. When the side window is closed, the first step of this protocol, I'm selecting both simulation also for the airbag. And once I'm clicking OK, you will notice that the tool opens up the report. And once the post-processing has been completed, the tool will open up one slide with a summary of these two, which we have selected, the glazing and the airbag. It takes some time. In a couple of seconds, we will have the results. And as I have already mentioned, we have now this summary report. In this summary report, as you can see, we have the type, glazing, and airbag. We are comparing the same points for the glazing and the airbag. The max displacement for each point has been written in the column max displacement, as well as the excursion. And excursion column means that it compares the same points for the glazing and the airbag. So this means that the difference between the point B3 for the airbag and the glazing lies in the safe side. We are -10. And the difference between the points B2, we have a red box, 257.087 is a value. According to this protocol, the displacement difference between these 2 points must be lower than 100 millimeter. And there is another point which I need to mention at that point. If we open up the settings window, as you have seen this previously, we have on the bottom the result overview settings, where we have the excursion tab. Critical limit is being marked red above values above 100, and the safe limit is between or above 80 and below 100. Regarding the max displacement, we have safe limits from 550 up to almost 800. Above 800 is the critical limit for the max displacement. Apart from these, let's inspect also the slides being created from our tool. I'm clicking the F5 button for the presentation mode. The tool has created or has post-processed and has created a report for both points of the glazing, and this is the first step of this protocol. The head form hits the side window, the so-called the glazing, when the glazing is closed, when the side window is closed. And the second step of this protocol is that the head form hits the open airbag when the glazing is open. The displacement difference between these two should lie below 100 in order to be on the safe side. Apart from these, the user has the ability to map the values on his model. In order to do so, he needs to go under the result overview tab, load his model. Let's say that we will load the first model, select the overview target point file, which is the TXT file. And once he does these, he has the option either to map the annotation or map the values on the model. Let's say that we will do these with both of them. We will select the map annotation. We will leave the map radius 30, and we will generate map result on visible. And as you will notice that according to the fringe bar which we have, the results has been mapped on the side window. Apart from these, the user can click the clear existing, change the tab, move to the annotation tab, select the option either name, value, or both of them, name and value, and map the annotation in a rectangular box on the glazing. You will notice that the point B3, according to the excursion window, lies above 100 according to the color bar or the fringe bar, and the point B3 is on the safe side. It lies below the 0.1 value. In such an easy way, the user can create and post-process according to the FMVSS 226 protocol. Apart from these, we have some new features supported for the massive tool, the occupant injury criteria tool. For this tool, as you might know this tool, I am using, or I will use, a configuration file. We will go through each point once the configuration file has been loaded. The tool can operate at the same time, or it can create results for more simulation, between simulation and test results. And since the last version, the tool has support also some human body model output. It can be used in order to output the results for the simulation and the test, as we have already mentioned. The user needs to define the result path at the beginning. He needs to select the file format for LS-DYNA, PEMCRASH, Radius, or PEMView. We have selected the LS-DYNA. He needs to also select the unit system. Once he does this, the tool is smart enough and the user doesn't need to select or to upload the dummy. The user needs only to select the impact type, front, rear, or side, the regulation, and the load case. Once he has selected these three options, the relevant or the respective dummies according to the front Euro NCAP MPDB load case will be inside the tab which is called occupant under the type. As you can see, we have the H350, the Thor 50, the Thor 50 AV, Q6, and Q10. Apart from these, the different versions of our dummies or human body models has been also supported in the version tab. Once the user has defined all the necessary fields, let me click the report output, he needs to click on the create curves button. Once he clicks on the create curves button, the tool searches for all the simulation. We have inside that folder one simulation. In order to keep this simple, I'm selecting the simulation and I'm clicking the OK button. Once we click the OK button, on the right top corner again, the tool creates some meta windows, and after the post-processing has been taken place, the report will pop up. Regarding the report, on the top of this report, we have again a summary overview. The reports are according to the protocols being created from our tool. And as you can see, in a couple of seconds, the complete report will be created, will have been created by our tool. As I have mentioned, we have successfully created the report. On the top, we have the summary or the comparison slide, and all the other necessary slides according to the protocol has been created from our tool. Regarding now the new swap plot feature, which we have from the version 22.1.0, let's say that we will select a different window. Let's say that we will select the neck lower. As you can see, we have 4 plots, and in order to change the position of the plots or swap the position of the plots, we will open up again the occupant injury criteria tool. We will select the result handling tab. We will select also the report output tab. And the next step which the user needs to do, he needs to select the 2 plots which he wants to change the position or to swap the position. Once he has selected both of them, he simply needs to click on the swap button. Just look inside the model window. We have changed successfully the position of these 2 plots. In order to change the position of these plots also inside the presentation, the user, let me make this follow. The user needs simply to click the button activate window, as you can see here. The button active window. Once he clicks this, you will notice that the position has been also changed inside the report, which has been created automatically by the tool. In such an easy way, the user can create the report through the occupant injury criteria tool and swap the plots. Apart from these, regarding the occupant injury criteria tool, we have supported also a new protocol for the side impact, which can be found also from the impact type. Let's select the side. The regulation is the IIHS, and we have supported the 2021 version 2, as you can see. Apart from the older version, we have also the version 2 supported. Let's clear up the database and proceed to our next tool, which is the IIHS structural rating. In order to activate the tool, the user needs to go again on the top, user toolbar, application crash and safety, IIHS structural rating. It opens up the IIHS structural rating window. This window has 4 tabs: the front impact tab, the side impact tab, the roof strength tab for the strength ratio, as well as the settings tab. The protocol version, which is supported from version 22.1.0, is a version 2, and we have also still the version 1 inside. We will see the difference between these two versions in a couple of minutes. And the new button, which is the user-defined limit for the side impact, has been supported also, and it can be activated from the check mark inside the settings tab, user-defined limits, where the user is able to define his own limits. Once the user clicks on the calculate button, we have again the same thing. The tool opens up the folder and he finds two simulations. We will select both of them. Once we have selected the overlay, he will overlay both of them in one slide, and we will click OK. The post-processing, according to the IIHS structural rating, is very, very fast. As you have seen, now we have the result. As you can see in the first window appearing inside Meta, we have two rectangular boxes. Both of them appear red. The first simulation has a rating poor according to the final intrusion, as well as the second simulation has a rating of poor, and it goes according to the final intrusion. Regarding the lines, as you can see in this model, in this cross-section of our model, we have the dotted lines being the max intrusion lines, and the final intrusion lines are the lines which are continuous. As you can see, if we zoom in this area, both of these points lies inside, they are lying inside the area which is the poor area. Apart from these, the tool creates also some other slides for the animation. These are two slides for each simulation which has been selected, and these are animations which the user can use. Let's do the comparison between the newest protocol and the older protocol. In order to do these, we will open up again the IIHS structural rating. We will deactivate the overlay intrusion plot. We will select the protocol version 1. We will move to the side impact tab, and we will select again the calculate button. In order to keep these faster, we will select only one simulation, and we will click OK. You will notice the main difference between version 1 and version 2. The same simulation for the old or with the old protocol has a rectangular box appearing in a yellow color. The rating is acceptable. The rating goes again according to the final intrusion. We have still some information inside this rectangular box. Notice the difference. Now the intrusion lies inside the acceptable. According to the lateral distance from the driver's seat center line, as you can see, the poor area starts exactly in the middle of a seat in the old version of this protocol, in comparison to the new version, which got stricter. The protocol has moved the poor area closer to the B pillar. As you can see, it starts from -10 in comparison to the older version of this protocol. In such an easy way, the user can create also the post-processing according to the IIHS structural rating, either for the newest version or for the oldest version. Related the report, if the user wants to create a report, he's able to do this by simply click on the report option on the top, new report. It opens up this window, click the OK button, and just simply drag and drop these windows inside the presentation and the report composer. And in such an easy way, the user can create also a report for the IIHS structural rating. Last but not least, in the field of our post-processor Meta, we have some new protocols being supported also for the pedestrian tool. Once I'm opening the pedestrian tool, you will notice that on the top, we have the protocols being supported. Let me expand this window. We have all these protocols being supported in that tool. The new one is the protocol, the Euro NCAP version 9, 2023. And the main difference between the Euro NCAP version 8 and version 9 is that now we have, for the lower leg, the APLI in comparison to the older version, which has the FlexPly. Apart from these, there are some options inside the setting window which has been changed. According to the older version, we have settings for the FlexPly. According to the newest protocol which has been supported, we have settings for the APLI. Not only the lower leg has been differences, also the upper leg has differences between the older version supported and the newest version supported. As you might can see, We have different settings for the upper leg when we are selecting the version 9 in comparison to the version 8, where we have more limits being taken into account for these protocols. Now, we have successfully also seen the new protocol supported in the field of pedestrian. We have successfully completed all the new and see all the new features and tools also in our post-processor Meta. Thank you very much for your time.